So this is the quiz review for 2.3 through 2.6. Let's look at number 1. Determine if the conjuncture is valid by the law of detachment. Remember, the law of detachment is if P then Q is true and P is true, then we can conclude that Q is true. So it's given that if a student passes classes, this is our P, the student is eligible to play sports. This is our Q. So Raymond passes his classes. Raymond passes his classes is confirming that P is true. So we have P then Q, check 1, and P is true, check 2. So therefore, Raymond is eligible to play sports. So now Q is true. So this is a valid statement. So all you need to put on the quiz is valid. Let's look at number 2. Determine if each conjecture is valid by the law of syllogism. So remember, the law of syllogism is if we have P then Q and Q then R, then we can conclude, if the two in the middle are the same, that P then R is a valid statement. So if we have the measure of A is less than 90, this is our P, then angle A is acute. That's our Q. If angle A is acute, so we just saw this, we said it was our Q, then it is not a right angle. So this would be our R. So we have if P, then Q, and if Q, then R. So the two in the middle are the same, so we can say P, then R. So let's look at the conjuncture. If the measure of angle A is less than 90, we just said that was our P. So that's our P. Then it is not a right angle. And that's the same thing as our R. So we have if P, then R. So this would be valid. So that's an example of the law of detachment in number 1 and the law of syllogism in number 2. Determine if each conjecture is valid by the law of detachment. So remember, in the law of detachment, we need to have P then Q is true and P is true to determine if Q is true. So we're given if two statements are congruent, so this is our P, then they have the same length. So then they have the same length as our Q. So we have segment AB is congruent to XY, so these segments are congruent. This states that the P is true. So that's true, and we have P, then Q. So therefore, we can conclude that Q is true. So they have the same length, so this would be a valid statement. So now let's look at number 4. Write the conditional statement and the converse within each biconditional. So an angle is acute if and only if its measure is greater than 0 and less than 90. So we need to write a conditional and converse. So we have the conditional which is P then Q. So we have an angle is acute is our P, and then its measure is greater than 0 and less than 90 is our Q. So we would have to write an angle is acute, then its measure is greater than 0 and less than 90. So then the converse is Q then P. So we flip them. So we have if an angle is greater than 0 degrees and less than 90 degrees, then it is an acute angle. So remember, our conditional is if P, then Q, and the converse would be the flip, if Q, then P. So now let's look at 5. Write each definition as a biconditional. So we need to make this an if and only if statement. And another word for if and only if is IFF. So biconditional means to turn it into an if and only if statement. So we have a shape, or we could say a figure, is a quadrilateral. If and only if it is a four-sided polygon. So remember, biconditional is not an if-then statement. It just has if and only if in the middle. So biconditional says P, if and only if Q. The measure of a straight angle is 180. So we would write an angle is a straight angle if and only if its measure is 180. So we have to make if and only if in this biconditional. Biconditional means we put if and only if in it, and it has to be a sentence that makes sense. We can't just put if and only if in the middle of this. We have to make it a sentence that actually makes sense. So we have an angle is a straight angle if and only if its measure is 180 degrees. Solve the equation -5 is equal to 3n plus 1. Write a justification for each step. So let's restate the equation. -5 is equal to 3n plus 1. And the justification for this step would be given, because it's the equation that's given to us. So now we can subtract 1 from both sides. And what did we do? We use subtraction on both sides of the equal sign. So this is subtraction, property of equality. And then all we do is simplify. -6 is equal to 3n. So this is simplify. Next step, we would divide 3 from both sides. We get -2. Well, before we do that, we need to write this step, which is the division property of equality, because we're dividing on both sides of the equal sign. And now we have -2 is equal to n, and we just simplified. If we want, we could skip steps, so I'll write it again up at the top. So this is a good answer, but we could also skip some steps, and we can just write -5 is equal to 3n plus 1, and this is given. And then if we know we're going to subtract 1 to both sides, so the next step would be subtraction, property of equality. And we subtract 1, and we can just write -6 is equal to 3n. And then we know we're going to divide 3 from both sides of the equal sign, so we know we get -2 is equal to n, and this would be division property of equality. So in this one, we just skipped steps because we didn't write each of these, which is also a good answer. But if you need to visualize it, this is also, you can just write it in the black if you need to see each step. So either one works, whatever works best for you. Let's look at 8. I accidentally forgot to erase the answers next to each of these, but I know most of you just did matching. So if you wrote this, that was good. But let's take a look. We have A, the measure of angle 1 is equal to the measure of angle 1. So we have the same thing is equal to the same thing. So when you're looking in the mirror and you see your reflection, so this is reflexive property of equality because there's an equal sign in the middle. So reflexive property of equality. Let's look at B now. We have xy is congruent to vw, so vw is congruent to xy. If I drew a line right here, the left side is symmetric to the right side, so this is the symmetric property of congruence because it uses congruent signs. So symmetric property of congruence. Now we have angle ABC is congruent to angle ABC. We have the same thing is congruent to the same thing. So again, this is reflexive. Oh, I spelled reflexive wrong here, but reflexive property of congruence because we have the congruent sign. So reflexive property of congruence. And now we have angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3, so angle 1 is congruent to angle 3. So we have two that are the exact same, and then we just took one of them and set it equal to the other, so this is transitive. And it's dealing with congruent signs, so transitive property of congruence. So now let's look at 2.6. We have geometric proofs. So let's fill in the blanks to complete the 2-column proof. So we have angle 1. We're given that angle 1 and angle 2 are supplementary, and angle 2 and angle 3 are supplementary. So we're going to write that because our reason's given. So we're just going to write the given into A. So I'll write it down here. A, angle 1 and angle 2 are supplementary, and angle 2 and angle 3 are supplementary. So now we're using the definition of supplementary angles, which is two angles add together and give you 180 degrees. Now it says we're using substitution. So let's look at 2, and what can we substitute into 2 to make to fill in the blank for step 3. Since we have 180 and 180, we know that both of these, the measure of angle 2 is equal to 180, so we can just plug this in to this 180. So we can get the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 2 plus the measure of angle 3. Now by the reflexive property, we know that the measure of angle 2 is equal to the measure of angle 2. And then let's take a look at step 5. How would we get from this equation to the measure of angle 1 is equal to the measure of angle 3? We have to get rid of the measure of angle 2's, these two, and we can get rid of them by subtracting the measure of angle 2 from both sides of the equal sign. So this would be subtraction, property of equality. And then in the last step, you're always going to put the prove, what you're trying to prove in the last step. But it says we're using the definition of congruent angles. So the definition of congruent angles says we can go from the two angles are equal to now the two angles are congruent. So we have angle 1 is congruent to angle 3, which is just what we're trying to prove. So last question. Fill in the blanks to complete the two-column proof. It's given that angle 2 is congruent to angle 3. So if you look at this picture, they put the arc marks there. So we have angle 2 is congruent to angle 3, which that's given. And then we go from angle 2 is congruent to angle 3 to angle 2 is equal to angle 3. And we know if two angles are congruent, we can say that they're equal because of the definition of congruent angles. Now the linear pair theorem, if we look back in 2.6 PowerPoints, we know that the linear pair theorem states that if two angles form a linear pair, then they are supplementary. So we know that since 1 and 2 form a linear pair, 1 and 2, they're on this line. So angle 1 and angle 2 are supplementary. So because of the definition of supplementary angles, we know that the measure of angle 1 plus the measure of angle 2 is equal to 180. Because we just said in step 3 they're supplementary. So now we can add them and set them equal to 180 because the definition of supplementary angles. And if angle 1 plus angle 2 is equal to 180, and we know that angle 2 is equal to angle 3, so we can take out this angle 2 and plug in angle 3 and get this equation. So since we took it out and plugged something else back in, C would be substitution. And then for D, because of so we know we're using the definition of supplementary angles. So we know that two angles that add to give you 180 are supplementary angles. So we can say that angle 1 and angle 3 are supplementary angles. And that is our proof.